Okay guys, welcome back. Let's recap. We explained how any point on that ellipse, because it's a moving point, the distance from that point to the foci PF1 being distance 1 plus PF2 being distance 2, you see that right here on the tablet, equals the 2a. And we explained how we got to that. And we said even when that P is right here, remember? So it becomes 2a, and this is how we are deriving these formulas. So now we went back into explaining and deriving why C equal A times eccentricity, right? And we set up, this is P, this is M. We said this is the directrix here. And we're gonna derive why this is AE instead of C0. And we're also gonna do why this is A, the directrix here, equal x equal plus a divided by e. On the other side, it's minus a divided by e, okay? Now, if we look at it, we took a point n here to make everything proportional. Like if we say, for instance, pm, okay? If p, look at p, where p is and where m. P is what? You take that as xy, pxy, right? And then this is your x here, and y is 0. So, and this is A1, vertex here, and A2. And then we said deriving and explaining is very easy. You just follow the eccentricity formula. E equals PF1 divided by PM. Instead of PF1, we put A1 F1 divided by, we imagine that P is at A1. So A1 F1, okay, divided by A1N, right? And this is where P is right now. So A1, and we can also say when P becomes here, the other distance becomes what? The other distance becomes A2 F1 to this, with respect to this focus point right here, A2 F1 divided by A2N, A2 F1, this whole thing here, divided by A2N, when this distance, when this point PB, is on top of A1. D1 plus D2, this is what they become, okay? And then if we go ahead, they become like this. A1 F1 equals E times A1N, and A2 F1 equals E times this whole thing, A2N, from here to here, okay? Now, if we are to minus them, A2 F1, what are we minusing? A2 F1 minus A1 F1, what do we get? We get that distance between F1 and F2. So we get two of those OF. So we get 2 OF1 or 2 OF2s. 2 OF1 equals 2C. On the other side, we got E, A2N minus A1N. What's A2N minus A1N? Here. A2N minus A1N. So A2N minus A1N. Look at it here. A2N minus A1N. That's the whole focal diameter. That's 2A. Look at it. A2N, this whole thing here, from here all the way to n, minus A1N, this distance here, this slack here, equals your 2A, your focal diameter. So 2C equal E times 2A, C equal A times E, okay? Or A times E is your C. So is this something for you to memorize? Again, that's up to you. I personally only not memorize, but I always remember that I have a squish, B is less than A, so I remember that B squared equals each element of the slack squared, like this, okay? And then I can derive whatever I want. I know that if you want to memorize C equal or AE equals C, that's more than enough, but you need to stop here because everything else you can get from these two, okay? So now let's go to adding A2 F1 plus A1 F2. Look, A2 F1 plus the other one, A1 F1, A1 F1 plus A2 F1. Now I'm gonna add them, and what do I get? If you add them, you're gonna add on the other side. Okay, so if you add them again, they're, you know, this is the moving point here. They equal A2 F1 plus A1 F1 equal D1 plus D2 equals 2A. Okay, they're the distance of a point that is moving around the ellipse equals 2A. On the other side, instead of A2N, let's move it to the board so you can see it. On the other side, instead of A2N, this whole thing, what can I write? I can write ON, this distance here, ON, right? ON plus OA, you know, OA, which is what? OA1, or you know, OA2. So OA2, this distance, plus this distance, makes what? Makes the whole thing. Makes A2N. That's all I did. Okay? And then the other one, A1, and the slack here equals what? Equals ON. I want to get the same element. Equals ON equals this. Minus what? Minus OA1, which is going to equal to the small a, minus this. Okay? So this one minus this gives me this small slack here. And that's all I did. I'm just playing with, you know, the distances around, because everything is centered around this 0, 0. Again, you don't need to know this derivation, but I need to show you how we got here. Okay? So if you keep calculating inside the parentheses, what do we get here? We get 2a is going to equal 2e. ON plus 2ON, that's 2ON. Plus OA2 and minus OA2, that's plus small a minus small a. Okay, that's 0. Okay, so now if I go to a new page, what do I get? I get my 2a equals e times 2ON. Okay, ON is your directrix, is your x equal what? This ON. This is your x, your directrix, equal a divided by e. Look at it here. ON is your directrix. ON, this is the distance between the 0, the center, and where x of the directrix is. So ON is the coordinate x of the directrix. So all I did was I did this. Look at it. I did ON equals A on the other side divided by E. And that's how I get the foci and the directrix are very similar. The foci is A times E. The directrix is A divided by E. Now, A minus here, this directrix on this side, name it, minus A divided by E. Okay? Now, I personally, again, don't memorize them. I just go by, you know, I have something on this side. It has to be positive, and it has to do with the A divided by this eccentricity. Because this eccentricity is a small fraction here. Okay? So this is between 0 and 1. How we derive it? I showed you how to derive it. How do you need to memorize it? No. You just need to, actually, this one, when they ask you about it, you don't need to memorize it at all, because you can get it from the calculation. C equal A times E, you might need to memorize it. You need this one. And you need, at the beginning, B squared equal A squared minus C squared. Don't forget that. And C equal A times E. That's all you need for now. Directrix is the opposite, is A divided by E, and we already proved that. Okay? Let's go back here. Let's see what else do we need to prove. A lot of formulas. Okay, the most important one, the one that, again, in books they make you, I don't make you memorize. Just look at this. This is the most important of all of them. Since you know that this one equals this one, okay, you don't need to memorize what's going to come now. Okay, why? Because look, What is C? What is C? We just found out that C equals what? A times E. So A squared times E squared. So this equals what? A squared factor 1 minus what? E squared. So what do I do here? I have 1 minus E squared on one side and B squared on the other side divided by A squared. So I can go E squared equals what? 1 minus B squared divided by A squared. And in most books you have what? You have it like this. I'm sorry. Keep this. You have it E squared equals 1 minus B squared divided by A squared, or you have it as E equal square root. And most students were like, what is that? Where does that come from? This is where it came from. I don't memorize it. This is so easy once you know that this is a squish, B is less than A, B squared equal the element of the slack squared, A2 minus C minus C2, and then you plug in what we just found out, C equal AE, A times E. And then you take a factor and you get your eccentricity squared, and then you can get your eccentricity as a square root, as a radical. Okay? Now, this is super important because they ask you about calculate and find the eccentricity, but this is how you find it, that's all you need to do. Okay, now, if you look back at the board, here, let's look back at the board, because remember the latus rectum? The latus rectum, this is the chord, that is the side that passes through the focuses, so we have two of them, and then we have 4 points, basically. We have L1, L2, L3, L4. Well, let's talk about this one now in the positive, X and Y's. So this L1 here is a side that is straight parallel to the directrix. So it has a coordinate of AE. How about the Y coordinate? The X coordinate is like the foci. It's C. It's A times E, right? How about the Y coordinate? That's what we're going to find out. And again, you don't need to memorize them again and again and again. The only thing you need to memorize is what I told you need to memorize. Even the eccentricity that they ask you about most of the time, you can derive it from that B squared, the squish, equals A squared minus C squared. Now, for the, here, let's switch back here. And let's do our latus rectum. So I have L1, this point L1 that I talked about is at X is AE. What is Y? The Y coordinate is F1, L1. What do I mean by this? This is what I mean. See it right here? This is L1. So it's point F1, L1. I called it L1 on the, on the ellipse, on the curve itself, okay? So switch back here. This point lies on the ellipse, so you can plug it in the function of the ellipse. And since this is at the center, there is no HK, there's no shift. So X squared, which is this one, A2 E2 divided by A2 plus Y squared, which is F1 L1 squared divided by B squared equals 1. Okay, James? Yes. I just, because it fulfills the equation of an ellipse. It is a point on the ellipse. That's why I put the Y and the X. Yes. So if you eliminate A, you get E squared plus F1 L1 squared divided by B2, B squared equals 1. Now, if you move F1 L1 by itself, F1 L1, and I square it, that's going to equal to B squared 1 minus E squared. Yep. Okay, now, what is 1 minus E squared? Look at it. 1 minus E squared. You see it here? 1 minus E squared. I don't memorize any of that. I only get it from this one, the first one, the squish. Okay, it's B2 divided by A2. So I go back here and I do this. This is equals what? B2 minus A2. So equals B2, I open the parentheses, 1 minus, what? B2 minus A2. I'm sorry, the whole thing is, B2 divided by A2. So what do I get now? 1 minus E squared equals, the whole thing equals B2 times A2. So now I get this. I get y squared, or, which is in this situation f1 L1 equals b to the power 4 divided by a2. So this one squared. So I get y, or f1 L1, equal plus or minus b2 divided by a. So I got my L1 at AE, B2, A, and the other point would be at minus B2, A, okay? So if I go back here, and let me go to the board and show you where all these points are, okay? So I have my L1, this one, at AE, and the y coordinate is B2 divided by A, okay? And L1 prime, the one that corresponds here, L1 prime, will be the minus. So it would be coordinate x equal A times E, and the y is minus B squared divided by A. Now if you go here, you take this as L2 and L2 prime, what do you get? You get, first of all, minus AE for the x, okay? And for the y, B2, it's in the positive. B2 divided by A, you know, that's all. That's the same thing. And for this one, and then L2 prime here, you get minus AE minus B2A, okay? Think about it as quadrant, 1, 2, 3, 4, okay? That's it. Again, no memorization except for B2 equal A squared minus C squared. The elements of that slack A minus C squared. And if you want to memorize C equal A times E, that's fine. The rest you can just, you know, derive them one from the other. You know, there's no need to memorize anything. You will forget them anyway, you know, month after month and year after year if you don't use them. So there's no need for that. One more thing in your books. You see in your books that they write this distance. Remember PF? These things keep doing this. PF1 plus PF2, or PF plus PF prime equals the 2A. They call it distance 1 plus distance 2. They have that distance sometimes, PF1 or PF2, written as like this. They have like PF1 equals A minus C over AX, or and PF2 equals A plus CA divided by X. And you'll be like, huh? More formulas? Well, again, that's, you know, don't memorize it. Just try to derive it. Go with the E equals PF1, right? Divided by PM. So if you want to go to just PF1, this is equals what? E times PM, right? And now that you know that E equals what? Exactly. OM minus OP. Look at the board. You need to conceptualize it. So this PF1, or I'm sorry, PM is OM minus OP. PM, right here, is OM minus OP. What does that mean? Or ON minus OP. So this PM, this distance here, okay, equals what? Equals OM, or ON, this whole thing, minus what? Minus OP. Minus OP. What's OP? Minus your X, okay? So if this point is here, it's equals OM minus OA. So it depends where the point is again. So basically, here, let's show you on the tablet also. Here, if I go here, let's keep rolling with this so you get the idea. So this equals what? Equals E ON minus OW. ON, what's W? Here. W is this point here. That's what I meant by W. W is this point right here, which has an X and the y is 0 because, you know, it's right. So on minus what? OW equals this WN or PM. Look at it. It forms a rectangle here. Okay? So ON from the center to the directrix minus what? Minus OW, which is the x, because W is the projection of P on the x-axis. Minus OW equals what? It's the same as OM minus OP. So that's why that equals PM. PM equals WN. It's the same thing. So I'm doing, instead of writing PM, I'm writing WN. Instead of PM, WN. And WN equal ON minus OW. ON is your directrix, is x equal A divided by E. And OW is just x. As simple as that. Because this W is the projection of P on the x-axis. So it has a coordinate of x. Okay, James? I'm using what I know to derive more formulas. So now I can go ahead very easily and say this is equal, this is my directrix, so this is A divided by E minus x. As simple as that. So where does that lead me? And you know that leads me to this. PF1 equal AE minus x, right? And you know that C equal A times E. So E equals what? C divided by A. So what do I get? So I'm sorry, this is times. PF1 equals this. So I get what? I get C divided by A times E minus x, right? All agree? Okay. So what do I get now if I keep going? I get C divided by E minus CX, right? Divided by E, if you want to put it this way. Now, if you don't want to put it this way, all you need to do is what? Exactly. C divided by E. So this is your A minus C divided by A times X. So it can go like this. You can put it like this. So you get PF1. So look at this. PF1 equals E. We said this is ON minus OW. Okay? Equals E A minus X, right? So equals what? A minus A goes like this minus EX. Done. You're done. And instead of E, what do you write? A minus C divided by AX. This is what you have in your books. Again, PF1 equals E. PF1 equals E times what? Times PM. Instead of PM, I want to put WN. And WN is ON minus OW. W is the projection of P on this axis. So equals AE. ON is AE minus X. And then I can replace E by C divided by A. And this is what you see in your books. Now, if you go to the other direction, on the other side, what do you get? On this side, we got what? Absolutely, yes. You got it, you know, in the other direction. So in this direction, we got A, you got PF1 equals A minus EX. If you go to PF2, you're going to get A plus EX if you follow the same, because for the F2, we use this what? Minus A times E for the C. That was your C, right? So in this situation, you can think of it like this. You get PF2 equal A minus C divided by AX. So it equals A plus C divided by AX, or equals A plus EX. Okay? Again, no memorization, but you need to sketch it on a small piece of paper. You need to be able to sketch it. And you need to be able to do this one. See where the W is here? This is the W. You need to be able to understand that instead of PM, in order for me to derive this formula, I'm using WN. And WN is ON, this whole thing, which is A divided by E minus OW, which is X. Okay? And then, of course, there was times E. So that's how I got this PF1. Okay? So W is the projection of P on the X-axis, which has the coordinate of X, of course, like P. When you take a point, you know, it's going to have, you know, this, yeah, the coordinate, the same coordinate of X on the X-axis. Now, I want to do one more thing, and I'm going to stop after that. I'm going to do the same thing in the vertical direction. What does that mean? Here, let's move here to a blank page. And if we have something like that, if we have, it's absolutely the same thing. We're not, if we take 0, we take it at the center, okay? We take F here and F here, and we take our A now here, the quantity under Y, we make the quantity under Y larger than the quantity under X. So we stretch it vertically. So what do we have? Now, look at this. Where is your directrix now? It's still A divided by E, but it's right here. It's Y. Y equal plus A divided by E. And I have Y here equal minus A divided by E. Okay, on the other side. That's what I wanted to get to. And, you know, this is your F, and this is going to be your latus rectum. So F is going to be 0. This one is going to be 0 for X, AE for F. And that's going to be your L1 for latus rectum. This is going to be the latus rectum like this. Your chords, your latus rectum chords. And this is going to have F1, L1 for X and AE for Y. Okay? So look, let's do it on the board, so you understand where I'm getting these. Let's do it on the board. So when we stretch it vertically, the quantity again under the X, the quantity under the X is gonna be less than the quantity under the Y. The quantity under the X is the quantity that is stretched or crosses in a horizontal direction. So if this is my 0, I have an F here, an F here, I have my A here, I have my plus A here, and I have B minus B plus B. And I go like this, and I have my directrix here, Y equal plus A divided by E. This one is on this side, Y equal minus A divided by E. Okay? Well, my F or F1, I call it F1, let's call it F1, is going to have a 0 for X and AE. Now, where is my L1? This is my latus rectum. This is L1 here. So L1 is going to have what? It's going to have AE as Y coordinates. So this L1 is going to have F1, L1 is going to have AE as Y coordinate. What's the X coordinate? Again, you plug it in that equation because it's on the ellipse. But this time you do like this. You go F1, L1 squared because this is the X squared that we want. And you divide the whole thing by B2. Now B is here. Look at this. Now B is here. This is 0. Look at this. B is here, okay? So I have a plus B here. I have a B and 0. And here I have minus B and 0. How about the F? We said the F is 0 AE, and this one is 0 minus AE or times AE. Okay? So in order to get that L1, F1, L1, and F1, L1 prime, this chord, this latus rectum, instead of x, this is my unknown, F1, L1 squared plus B squared, because it's stretched vertically. So the smaller quantity goes under the x, plus this one, A2, E2 divided by what? By A2, because I moved the A2 under the y, because it's a vertical stretch. Again, I did that. See how when you did that and when we didn't memorize if B is more than A, we don't need that. So this way I know what I'm doing. And I look at this. Okay, so F1, L1 in this situation goes to, you follow the same procedure and you're going to get the same number. You're going to get it as B2 divided by A. So you're going to get F1, L1 equal squared. Remember how we did it squared? It's going to equal B4 divided by A2. And then F1, L1 will be B2 divided by A. Plus, this is a plus. So B2 divided by A. You're going to get it like this. And for what? For L1 prime, it's going to be minus, this one is going to be minus B2 divided by A. For the X, for the Y, it's the same, A times E here, okay? Now, for L3, if you want to go here, where's my green? I have a red one, okay. For this one, if I want to call this L3 and this one L4, what do I get? James, any idea? Yes, minus AE for what? For the Y's. And for this one is B2 divided by A minus AE. Okay? And L4, if you call this L4, what do you get? Minus B squared divided by A, and again, minus AE, you're in the negative. Okay? So you need to sketch it on a scratch note. You don't memorize these. You don't memorize the latus rectum, F1, L1, if it's vertical equals to minus plus B. You don't need to do that. You're going to forget that. That's very confusing. All you need to do is start with quantity, if it's vertical, under the x squared is the smaller quantity, so that's B2. And I want to find what? I want to find that because, I don't know it. I know the y here, okay? It's AE. So I just put that distance. You can put this as a distance, D squared, or F1, L1, or F1, L1 prime. And then you're going to get to the same conclusion. That's F1, L1, or F1, L is going to equal plus or minus B squared divided by A. If you're here, it's plus B2 divided by A. If you're here, it's minus B2 divided by A. Okay? That's it. That's what I think that should suffice. Let me see. There is a very important concept that I want to keep it for next time just by itself for the tangents to the ellipse. One more thing. Maybe we can do this one because we already touched on that. Here. So if I am in the vertical, here, look at this. Okay, let's do this here. O, this is called this F1 at 0 like we did AE, okay? And I want to take this as, my A here. This is F2, 0 minus AE, okay? And I want to finish the ellipse like this, like that. Okay, and this is my, let's say this is my directrix, y equal A divided by E. If you take a point here, P, and you do PF, this is your PM, and then you can get your calculation by doing an N here. Remember how we did that? Okay, and where is that W that corresponds to the X? It's right here. This is my W that has exactly, and the same it's a projection of P on the Y now. It has the same Y as P. Yes, yes, Lisa. Okay, and then if they ask you, I want, okay, and this is your O, okay, and what else? O, W, so I have it like this. Let's draw it better. So I will just draw it without the ellipse now, so you understand what I'm talking about. This is the O, this is the F1, this is the W now. That's your A, this is the end of the ellipse here, so that's A here. From O to A, this is A, this is small a. From O to W, OW is your Y now. And O, F1 is what? What's F1? It's 0 AE. Follow me? And this Y is the directrix here, Y equal A divided by E, okay? And if I take a point P here, okay, this is my PF1, this is my PM, I can call this N now. So I have N, A, W, F1, and O. I'm doing all that, I'm trying to conceptualize it because I don't want to memorize anything, okay? So, and if they ask me about, remember, what is PF1? I can go PF1 equals E times PM, right? And PM is what? It's that distance between the P and the M. So it's like the same as what? As WN. I just told you that. So it's like ON minus OW. Okay? All I did, I played that W game again. So I set PF1 equals E ON minus OW. Okay? And ON is my directrix up there. So equals E A divided by E minus OW, which is a Y now. I'm not playing with X's. W is the projection of P on the Y axis. Exactly. So this equals A minus E times Y. And if you want to, A minus C divided by A times Y in your book. So when it's vertically, that's how you do it. So all you need to do is sketch on a piece of paper the projection of any point. Call it P, call it Q. If it's vertical, on the y-axis. If it's horizontal, on the x-axis. And instead of PM, see where the M is right here? I go WN, this rectangle here. And WN is ON, the whole distance, minus OW, which is what? Which is my Y. Okay? Now, if you flip it the other way, you know, if you want your, here, let's do this and finish and sum it up with this. If I want my PF2, okay, PF2 is going to equal what? Is going to equal A plus EY, or equals A plus C divided by A times. But why? You're going to tell me, prove that to me, you know, same way, you know, with this W. So, but here, the thing is, I'm going to go WN prime equals what? Equals Y, the W, plus AE. Look at it. Okay, where is WN prime? It's right here. Where is that thing? Here, right here. So WN prime, what's N prime? It's your directrix here, Y equal minus AE. And why did I take this one? Because look carefully. If you take PF2 here, if you take PF2 and you deal with a reference, this directrix up there, PM, that's going to be way, you know, bigger. PF2 is going to be bigger than PM. So that's why you have to deal with PF2 and this M prime here. Okay? So this way, your WN prime equals Y plus A divided by E. So look. Let me do it on the board for you. Yeah. And let's finish with this. Okay, that's the last thing we're going to do for this. We're going to keep the tangent and the director circle of the ellipse for the next lesson. Be it this afternoon, be it tomorrow, we'll see. So, here. So I have an O, and I have an F1 and an F2, and this is my ellipse here. I'm not worried about the shape of the ellipse. Okay, this is my B, that's fine. This is my A. So from here to here, it's my A. If I take a point P here, and I have my directrix up there, Y equal A divided by E. This is my F at 0, AE. This is my P, XY, and this is the projection of P, which is W, which is 0 and Y. Okay, so OW equals Y. ON, remember this is N, this is M. ON equals A divided by E. Okay, that's your Y in the Y direction. And we already proved what? We already proved this. We already proved that's PF1, this is F1, PF1 equals E times PM. This is PM. But instead of PM, I always want to go with ON minus OW. ON, this whole thing, minus OW. I want to go with this WN. I make that rectangle. I project on the Y. So, equals E times WN equals E times, I open the parentheses and I put ON minus OW equals E. This is ON in the Y direction minus Y, and I got what? I got A minus EY, or A minus what? What's E? C divided by A. That's what you find in your books. And they tell you, oh, this is what it, you don't need to memorize it. You need to sketch it, understand it, use the projection of any point on the Y when it's vertical. Okay, now we're going to do it in the other directions. What does that mean? We want to get PF2. Where is F2? Right here. F2 is what? It's 0 minus AE. Okay? But look at it. PF2 divided by PM. PF2 is way bigger than PM. Uh-oh. So that's not going to be a fraction. That's not going to be, E is not going to be between 0 and 1. Exactly. What do you think? Yes, Lisa, yes. We're going to use the reference as this one. This other directrix. Y equal what? Minus A divided by E. And look, and if we do that, what are we basically doing? We are going, this is A and, right? Goes like this. And now I have PM prime. So E equal PF2 divided by PM prime. What is PM prime? PM prime is like WN prime. So PM prime is like WN prime, right? So if I want to get PF2, I have PF2 equal E times WN prime. And what's WN prime? WN prime is Y plus AE. W from here to N prime is Y, this is Y, plus AE. Okay? So equal Y plus A divided by E. All agree? All you need to do is just, again, conceptualize this whole thing and everything becomes so easy. Yeah, okay, yeah, you keep going. You just keep going with this. So, equals EY plus A equals A plus EY, or equals A plus C divided, exactly, C divided by A times Y. PF2. In your book, you have PF1 equals A minus C divided by A times Y, and PF2 equals A plus C divided by A times Y, and they give it to you as, you should know that. No, you should not memorize that. You're going to forget that. You need to understand that this time we used as a reference this second directrix on the other side, because this makes PF2 less than PM prime. That works. E stays between 0 and 1. Okay? And we use this. We projected P here. We use this rectangle. So instead of PM prime, we use WN prime. And that's how we come up with these equations. We don't memorize them. Okay? On that note, I'm going to leave you. Again, I will just remind you that's the only thing you need to memorize if you want to, always do well, even in a test. You want to memorize this. The squish, B squared equal the element of the slack squared. And you can memorize this one if you want. The directrix, it comes, because if you're in the x, you know that the directrix is going to equals x, and you can get that, from the distances that we did, a divided by e. The rest of this, I don't memorize anything. Remember the most important one, this one, I said we do like this. And then we take a, and we get 1 minus e squared. And then you take the 1 minus e squared to the other side. If you take it like this, is going to equal to what? B squared divided by a squared. And then you get a squared equals what? E squared equal 1. And then you move that to the other side, minus b squared divided by a squared. And e equal the square root or the radical of 1 minus b squared divided by a squared. Okay, so that's all you need to know. The rest you need to conceptualize it. There are tons of formulas depending on how you move this ellipse vertically or horizontally. So basically, we cannot memorize all that stuff. All we need to know is the following. B squared equal a squared minus c squared, c equal a times e. If you want to just memorize this or know that, if you don't want to do the distance, the thing that I do with the projection, you can also memorize this one. The directrix equals a divided by e. If the ellipse is stretched horizontally. If it's stretched vertically, then it's going to be y equal a divided by e. And then the most important thing that I want you to conceptualize and be able to scratch on a piece of paper is this one. Where did I draw this one for you? I believe right there. Yes. Be able to do this. See how I took p m prime here, and instead of using p m prime, I used w n prime. And I said, I used OW as a y, because this is a projection on the y-axis. And, this ON prime is just the magnitude of A divided by E. That's all I did. Okay? And that's it. Next video we will be dealing, or next lesson we will be dealing with more real-life examples. But before we dig into that, we're going to explain one more important rule. It's called the restriction rule of the tangents to an ellipse, and we're gonna find out and calculate the director. We already talked about the concentric, the inner and the outer concentric circles of an ellipse. We talked about the auxiliary circle. But the director circle of an ellipse is different of a director circle of a circle. Remember, the director circle of a circle has a radius of square root 2 times the original radius. This is different here. So we're going to deal with that, and we're going to give more real-life examples before we wrap it up and finish this very lengthy introduction for you. Okay? Thank you.